Alright, so continuing with our particle shield generation stuff, we're going to take a look at one more example. So what we're going to generate is like an actual sort of a polygon based shield. So using something like a Voronoi fracture. So every time a particle hits, it generates this sort of Voronoi based shield. Okay, so that's what will be our final example in like shield generation using particles. So what I'm going to do is the base is the same as our previous lesson, which is I just have this particle network and I have these particles hitting, and then it generates a secondary particle which just fades out. So exactly like what we were doing with our shape-based shield. So I'm going to take this as the base and then we'll continue from there, because this will be just a repeat, like it is exactly, what was happening before. So I'm going to copy this. Okay, so we'll do Control C and I'll just take that to a brand new file. Okay, so this is good. I think let's just play this and see where we are. Okay, sorry, the name was slightly different, so it was causing an issue. Yeah, this is good. Okay, so the first thing we'll do is we're going to create the shield that we want. So we'll start off with a simple grid, and I'm going to make it like 1 by 1 in size and 2 by 2 in rows and columns. Okay, so what we want is we want to fracture it in a way that we have more points on the edges and less in the center. So I want like big chunks in the center and it sort of becomes smaller as it spreads out. And in order to do that, I'm going to take a subdivide because there's no geometry in here. So we'll just take a subdivide and give it a depth of 6. Okay. And then I'll take a sphere and make it relatively small. Okay. And then we can use a mask from geometry. Yeah, just adjust it so that you get the radius down to around, let's say 0.5. I think 0.5 should be good enough. And if we use the mask attribute for scattering, right, so if I just take this and do a scatter, and I'll set the density attribute to mask. See, so you're going to get this. But what we want is the reverse of this. So just take the mask from geometry and flip this. Okay, so you'll get that. Now we don't want these many points, so bring this down to around 40. So you'll get this, which is good enough for what we want. Okay, now take a Voronoi fracture and turn off create interior surfaces and bring in the grid here and the scatter points, and there you go. Okay, so you have like big chunks in the middle and smaller over there. And if you want, we can sort of make a few more adjustments like this. See, so I can get it to be more, sharp like that. Okay, now what I also want to do is I want to bring the mask attribute over to my Voronoi fracture so that I can use it later on for coloring and stuff. So come down and you'll find a tick mark called copy cell point attribute. So turn that on and copy the mask to the piece primitives. Now, if you just want to check it, we can take a color node and I can plug this in. And I can take a ramp from attribute and type in mask. And you can't see it because the default class is kept to point. So just change it to primitives and there you go. And then we can flip this again. See, so this is what we have, which is nice. Okay, now let's do a couple of things. I just want to scale this down a little bit. Yeah, I think this is okay. Okay, so now what we want is I don't want the border, so that we get like this little irregular shaped shield that we want. That's the reason for doing all of this. Okay, so what I can do is I can just take a delete and say delete by expression and do at mask less than 0.8. Okay, sorry, greater than 0.8. Yeah, there you go. So we have this. This is nice. So this takes care of the first thing, which is this is the shield that we want. Now in our particles, we are already generating, the basic particle that we want. And I figured out the issue that I was having with trying to separate the pop replicate from the original, where it wasn't showing up. Like I had to do that null and a switch thing. So I think I figured out what the issue is. So what you want to do is you want to take a blast, and this is called stream hit point. Okay, and we'll do delete non-selected. And as usual, the problem that happens is you get like these guys, the original showing up, and then once the first pop replicate shows up, then they stop showing. Okay, so what you want to do is the group type, instead of guess from group, you keep it to points, and that takes care of it. See, so now the original ones don't show up. So I'll put this in as a as a note in the previous video that I recorded. So because I was sort of wondering how to do that, but then this is what you have to do. Just change the group type from guess from group to points, and it sort of takes care of it. Okay, so this is good. We have what we want, which is these points are in place. Now we want to do a couple of things. Firstly, I want to create like a normalized age attribute on this, and then I want to use that for generating like a fade attribute, because what we want is that when it default, these will be scaled down, and when the particle hits, they'll scale up. Okay, so when the hit happens, it immediately appears and then it slowly fades out again. So we want to do that based on the age of this particle. So what we do is we'll take a wrangle and let's create f at new age is equal to the same thing, fit and at age comma 0 comma at life comma 0 comma 1, and then this goes into f at fade, and we'll do ch ramp, we'll call this fade as well, and we're going to use the new age, so at new age, and this will go into scaling. So just click plus over here, and what we want is that it the scaling should be a little bit like this, like it's small in the beginning and then it sort of immediately scales up, and we'll keep all the types to B-spline, and then it sort of stays there for a while and then it fades out. So something like this. So it immediately jumps up into shape. Okay, and then it slowly sort of like it remains for a while and then it slowly fades out. Now along with this, what we also want as a final thing is that for each hit you get a different shape. So that is going to be based upon the seed value over here. So we want for each point or for each particle, the seed should keep changing. So what we want to do is we want to base the seed on the ID value of the particle. Okay, so I can just take this and we'll create, let's do f at seed is equal to at ID, and we're going to transfer this using a for each. Okay, so for each loop or for each point, it will sort of put the seed value into the scatter node. Okay, so let's just set this up. So this is kind of done. So what we want is we want to do a copy to points, and we don't want to bring in, because this has a ton of attributes, right? So we don't want like all of this. So just get rid of the star over here. And what we want is we want fade and we want new age. Okay, like those are the two things that we want. And so I can just plug this in over here and plug that in, and you'll get this. And what we want is just do a transform and rotate it minus 90. So it's facing where the sphere is facing, like that. Okay, so this is good. Most of our stuff is already in place. Now what we want is this should have the fade value. See, so there you go, it has the fade. And we want to use the fade for scaling the primitives. So so we want to move, so the first thing we need to do is we need to move the fade value from point level to primitive level. So let's take an attribute promote, and we will promote the fade from points to primitives. And let's also do one more thing. We'll take another attribute promote, and we're going to go reverse, because the color is at primitive level, but we want the color to be at point level. Okay, so this is fine. So we have our fade in there, and now all you need to do is take a primitive node and set this to do transformation. We'll right click here, do copy parameter, paste relative reference for both the axis, and I can just use at fade. And if I've done everything right, there you go. See, it scales up. Now, the only problem we have is that the shape for all of them is the same. So we need to change that. So what we do is we're going to take a for each. So take a for each point. This comes in here, and then that goes in there, and this comes out. Okay. And then this finally comes in here. So just the copy to points is inside the for each. And we'll call this, I'll give it a shorter name. So I'll just call it for each A. And the way to get the seed value into the scatter is using a point function. Now, if you want, or if you don't understand this, I have a for each video on my YouTube channel. So you can kind of look at that, and that will explain this whole thing to you. So what you need to do is just take a point function, and the point function requires 4 things. Like, it requires which node we are going to. So we're going to the for each, so for each A, and then which is the point number. So the point number is 0, because every time, like for each loop, it's just 0. And then what is the function or the value you want to call? So that value is seed, and it's again going to be 0. So it's like the 0 over here is it a vector or is it a float? Okay, so that way, and then I can just close it, and there you go. So now what's happening is for every hit, you're getting a different, see. Okay, so now as a final thing, what I can do is I want this to sort of wrap around the sphere. So I can take a race op, and I can plug this in here, and I can take the out collide and plug it into the race op and do minimum distance. See, there you go. And just kind of lower the scale so it doesn't fold completely over it. See, so now you have like this. See, it sort of folds around that. Okay, as a final thing, I want to do 2 things, which is I want to color this. So let's color this using the existing color that we have, or you can use the mask, like that's also fine. But let's just do ramp from attribute. We'll use CD. Yeah. And then I want this to be like a blue or something. And yeah, let's get this to maybe like a dark blue. Yeah. And let's get the center to be slightly brighter. So we'll make it about 5. Yeah, okay. And then the final thing I want is I want it to sort of fade as well. So let's take an alpha. So we'll take a point node, and I'll set this to alpha. And we do have the new age over here as well. Okay, so I can actually just take the same CH ramp from here. So let's do Control C, and we'll come here to alpha, and I'll do like Control V into value. So this gives me like an additional control. So let's bring it up, and this will be the same curve. You can bring in the fade value itself, but this gives me like a little additional control. So I can set these both to B-spline, and this comes up like that, and then it sort of fades out. Yeah. So you'll get, see. Yeah, and that's pretty much it. So this is how you can generate a Voronoi based shield. Now, as a final thing, let's do one more thing over here. So I'll do a Control C, Control V, and delete non-selected, or delete selected. So we have like the hit points, and let's say you want to turn these into like mini bullets or rockets or something like that. So what I can do is I can take a trail, and I'll give it like a little bit of a trail here like that. And then let's take an add, and I want to connect these into lines. So what you want to do is take a polygon, like go to the polygon tab, go to by group and set it to by attribute. And what it does is each set copies the ID value. Okay, so just type in ID. So each line automatically just connects. Okay, so this is good. And then I can take a resample. So I can sort of resample it a bit and set this and turn on curve view. Let's also take a carve. I want to make it slightly shorter, not from the front, like from the back. Or let's do this like beforehand. So the resample comes in afterwards. Okay, and then lastly, I'll just take a wrangle and I'm going to set the P scale to the curve view. So we'll do at P scale is equal to chramp. We'll do shape and it'll use at curve view. And I'll just shape it like, hold on. Yeah, always set it to B-spline. It probably gives you the best control that you can find. So just take this and then I want to sort of fade it out like that. And then take a sweep. So this comes into the left input and we'll set this to round tube. There you go. Just hit reverse. So it's, pointing outwards, and then get the radius really down. So then you can sort of shape it any which way you want to. Okay, like it gives you a nice little shape. And you can also take a color node and I can set it to ramp from attribute and call it curve view and flip it, and let's make this blue as well. So you should get, see. And so if we merge these together, and we might have to give this like an alpha value as well. So let's just take a point, because the Voronoi fracture has alpha. So if this doesn't have, it will cause problems. Okay, let's just keep it to a constant value of 1. And so if I merge these two together, I should get, something interesting. See, yeah, so if you press play, there you go. So this is a nice example of how you can use your basic particle system and then further sort of build on it using your standard sort of procedural modeling tools that Houdini gives you. Okay, now continuing with this, in the next chapter, we're going to take a look at the rainfall system again. But what I want to do with it is just to sort of modify it using the same techniques that we're doing here and create something slightly more stylized. Okay, so just to sort of take the basic particle system and apply more sort of procedural modeling stuff on it and get something a little more interesting.